All right, next one up. Here we are. The question reads 8 minus 0.5x equals 5. All right, so we have a negative, we have a decimal, and I think we can all agree that if you don't like negatives or decimals, this problem might drive some anxiety through the roof. So let's handle it like we know how by understanding the process, not the numbers. The process is get the x by itself, and we're going to work backwards one step at a time. So if I'm thinking about working forwards, I know that I will multiply x by 0.5 first, and it's a negative 0.5. And then at the end, we'll just merge it with the 8, and that's going to be addition. Everyone help me out. One more time. If we just see the number 8 sitting there, what operation is that? What does that count as? An 8 that's just sitting there counts as what operation? Yeah, it counts as addition. It's just being added there. It's just being included there, and we can consider that, hey, it's just being added there. So with that said, here we go. We're going to work backwards. The opposite of just adding 8 is going to be to subtract 8 on both sides. Now that we're here, we cancel on the left, leaving us with negative 0.5x, and that's going to equal 5 minus 8. Just like we've been talking about with handling negatives, 5 minus 8 is the same thing as 8 minus 5, but we're just keeping the sign of the bigger number. Everyone, the bigger number is 8, so 5 minus 8, that's 3, but negative 3. Now we're at the last step. Last step here is going to be to get the x by itself by dividing both sides by 0.5. But we make sure we include that negative so that way we can cancel the negative out as well. So here's the convenient part about this. The convenient part about this, everyone, is that the negatives are going to cancel out right here and right there. Nice and easy. We also have the cancellation of the 0.5 on the left side, which we can write x by itself as now. Now we can use our rule for dividing by decimals to finish this up, because currently we have 3 divided by 0.5. And the rule for dividing by decimals is to not divide by decimals. We'll go ahead and move the decimal place over to the right one time. And guess what? If we move the decimal to the right one time on the bottom, we'll do the same thing up top. And that's where that 0 is going to come into play, because we're going to have 30 divided by 5. One more time, 3 divided by 0.5 is the exact same thing as 30 divided by 5. It's the exact same thing. Everyone, what is 30 divided by 5? That gives us 6, and that's correct. That's why the correct answer here is answer choice D, 6. All right, new problem. And we're going to start the same way here. So we'll begin by reading that question sentence. So here it says, how much ribbon remains? So my party people, whenever we hear that phrase, how much of anything remains, we're thinking about subtraction. And I can see that in the chat box. We're definitely on that there. Good. So when we realize that, don't assume, we want to verify, right? We want to take the clues and verify them. But let's see what the situation's presenting. It says our friend here, Maria, has this much ribbon, and she uses this much ribbon to wrap a gift, and then she uses that much ribbon for a decoration. How much ribbon remains? Okay, everybody look. Before I even think about the fractions, because this is how you're going to be able to tell whether the word problems or the fractions of the numbers are the bigger problem. Let's figure out which is the bigger problem. So when I think about this problem overall, it sounds like Maria starts with a certain amount of ribbon. Then she uses some to wrap a gift. Everybody, when we're thinking about how much ribbon is left, if we started with this much ribbon and we use this much ribbon for a gift, what are we going to do with the amount from the gift? We are absolutely going to do what operation? Yeah, that's going to end up being subtraction. That's going to end up being subtraction because we start off with this much ribbon And then we are going to subtract what we used for the gift. And on top of that, we use some more for the decoration. And so for that decoration, we are also going to subtract that as well. So remember, everybody, if you can get to the point of understanding that we are just subtracting twice, then you can feel pretty good about your ability to solve the problem. If you're stuck on the fractions, that's just an indicator that you need to practice your fractions. So with that said, let's tag the numbers now. The fractions here are 7 over 8. We'll be subtracting the gift, which is 1/3. And then we'll also be subtracting the decoration, which is 1/6 of a yard of ribbon. And so there we are. We'll be subtracting 1/3, then subtracting 1/6, but we must make sure that we follow these core principles of fractions, which is we need the same denominator. The problem here is that we have, well, guess what? We got 3 fractions with 3 different denominators, and if we're feeling overwhelmed by this, hey, no worries, I totally get it. That's a reasonable way to feel. And I'm going to help us walk through this. Let me just make that a little smaller, and we can handle this one at a time. Later on, as we get better, we can handle all 3 at once, but for right now, for the sake of this problem, let's handle it one at a time. So here we go. I'm going to start off with the 7 over 8 minus 1/3. Everybody, what number can 8 and 3 both multiply up to? Because 3 can't go into 8. That's not clean. So we need to figure out what they can both go into. And I see that we're saying 24. And that's going to be the smallest number. That'll be the least common denominator. Again, we'll call that LCD. It'll be 24 amongst the 2 of these. We can also use 48 and 72, but we don't need to go that big. The smallest denominator is always best. So here we go. Everybody will multiply 8 by 3 to get 24. So we'll multiply that 7 by 3 to get 21. The 1/3 over here will multiply by 8 to get to that 24 denominator. 1 times 8 is 8. So from here, help me out, everybody. What is 21 minus 8? 21 minus 8 gets us down to 13. And remember, we'll keep the denominator the same. So right here, the 7 over 8 minus the 1/3, this turns into 13 over 24. We'll bring down that minus 1/6. And all we have to do is calculate here. Everybody, we don't have the same denominator, but answer this. Can this 6 right over here, can the 6 go into 24? Can 6 go into 24? Yeah, absolutely can. And that factor that we're multiplying by is 4, because 6 times 4, that gives us 24. And that's what we want, that denominator of 24. So we'll have 13 over 24 minus 4 over 24. Again, 1 times 4 gives us that 4. And now we just have to subtract here one last time. Everybody, 13 minus 4 gives us what? Yeah, that'll be 9. 9 over 24, but it looks like we have one more roadblock before we can actually get the final answer. Everybody, what is that S word I'm looking for that I'm going to be applying right here? Yeah, that's going to be simplify. We will simplify. Remember that simplifying is just, again, simplifying the way the fraction is written. So here's what that means. I'm going to divide the same number from the top and the bottom. Everybody, what number can be divided out of 9 and 24? Yeah, that'll be 3. In the same way we can multiply the top and the bottom by the same number, we can divide the top and the bottom by the same number. That's what simplification is. And from there, 9 divided by 3 gives us 3, and 24 divided by 3 gives us 8. And there's our final answer, my party people. The answer choice here is answer choice C, 3 over 8. We had to go ahead and subtract some fractions, simplify, change denominators, but at the end of the day, there's our correct answer. On to the next one, right?